Hello children and welcome to your channel Sharda Educare, and in this video we are beginning with problem set 05. We have already done 5.1 and 5.2 and now today we are going to complete problem set 05. So let us begin. The first question is fill in the blank using the correct alternative. The sum says segment AB is parallel to y-axis. So this is y-axis and this is x-axis. So the line AB is parallel to y-axis, means the line will be here or it can be here. Anywhere on the x-axis it can be. But it is given that point A is 1, 3. Of line AB, point A is 1, 3. So x coordinate is 1. Here 1 and y coordinate is 3. Somewhere here the point A is. Somewhere here not it is here only. This is point A. Okay. So the line is passing from here. That means line is passing from 1. So this is your A point of line AB. Then coordinate of point B will be what? If this is your line A, B and point B lie on the line, then its x coordinate will be nothing but 1. Yes or no? It will be nothing but 1 because the point is lying on this line. Anywhere it can lie, but x coordinate should be 1. Let us see in the option which option has x coordinate as 1. This has 3. No. This has 5. No. This has 3. No. Yes, this has 1. So your x coordinate of point B is 1 here. So 1 and another y is minus 3. This is minus 1, minus 2 and minus 3. So somewhere here the point B will be 1 comma minus 3. See children, why we chose option D? Because point B is on this line and it is parallel to the y-axis. If the point B is on this line and its x coordinate will be always 1. Its x coordinate will be always 1. Anywhere it can be. Suppose if it is here, then it will be what? 1 minus 2. Suppose it is here, 1 minus 1. Suppose it is here, 1 comma 1. Suppose it is here, 1 comma 2. That means somewhere here it will be. But it can never be other than 1. If I will take 3, 0, see, 3, 0, the point will be here, which is not lying on line A. So for the point to lie on line A, x coordinate should be 1, and therefore option D is the correct option. Question number, sub question 2 of fill in the blank from problem set. What does the question say? Out of the following point which are given, one of the point lie to the right of the origin. This is the origin. Right of the origin means on the x-axis, and it is mentioned on x-axis. So we have to first plot all the point and then find out which point is lying on the right side of the x-axis. This is left side of x-axis. This is right side of x-axis. Let us see which one lies. Minus 2 comma 0. This is here. Minus 2 comma 0. This is right side and this is left side. Sorry. This is left side and this is right side. Okay. Your right is the right and your left is the left. So minus 2 comma 0 does not lie to the right on the x-axis. 0 comma 2. 0 comma 2 means somewhere here. This point is 0 comma 2. So this is also lying on y-axis. So this also doesn't. 2 comma 3. 2 comma 3 is here. This point lie on right side but not on x-axis. Okay. So even this point will not lie. Now 2 comma 0. 2 0 step on y-axis. So 2, 0 lie on the x-axis, and that too on the right side of the x-axis. See, this is left side and that is right side. So what is the correct option? D is the correct option, children. Sub question 3, fill in the blank first. Distance of the point -3, 4. Let us see where is the point -3, 4. This is origin 0, 0. So 1, 2, 3, 4, 5, 6. And this is -1, -2, -3. 1, 2, 3, 4, 5 and 6. So -3, 4. So here is 1, 2, 3 and 4 and 5. Let us plot this point, children. -3. -3 is on x-axis and 4 steps on y-axis. Means this point is here. -3, 4. So what is the distance of this point from the origin? Means this distance. You want to know this distance. So children, you can do this by distance formula. So by distance formula, because see, you want to find out the distance between the 2 points, and if you want to find out distance between 2 points and the coordinate of those 2 points are given, then you can find it by the distance formula only. Let us say this as A and this is O. O is the origin. So coordinate of A is -3, 4 and coordinate of O is 0, 0. So this is x1, y1 and this is x2 and y2. You know by distance formula, AO is equal to under the root x2 minus x1 the whole square plus y2 minus y1 the whole square. Under the root x2 is 0 minus x1 is -3 square bracket the whole square plus y2 is 0 again, then minus, and y1 is 4 the whole square, which is equal to 3 the whole square plus -4 the whole square, which is equal to 3 square is 9 plus -4 the whole square will be 16. 9 and 16 will be 25 under the root, and under the root 25 is going to be 5. So the distance of the point -3, 4 from origin is going to be 5. So option C is the correct option. Question number 2 of problem set, determine whether the following points are collinear or not. Children, to determine whether the points are collinear or not, we can do it by slope method also. But slope method is not there this time for you, as it is coming under reduced syllabus for SSC. So we will do it by finding the distance of three distances and then comparing with other 2 distances. Let us see it. First we will find out AB by distance formula. By distance formula. So AB is equal to under the root, let me take it as x1, x2, x1, y1 and x2, y2, x3, y3. So this is x2 minus x1 the whole square plus y2 minus y1 the whole square under the root x2 is how much, 1 minus x1 is 0 the whole square plus y2 is how much, minus 0.5 the whole square minus 0.5 minus y1 is 2 the whole square. Let us do it. 1 minus 0 is 1 square plus minus 0.5 minus 2 will be minus 2.5 the whole square, and minus 2.5 the whole square would be 1 plus 1 square would be 1, and 2.5 means 25. 25 square is 625, and let me write here 625, but point will be after 2 digit and minus will become plus. So 6.25 plus 1 will be 7.25. So it will be under the root 7.25. That is AB. Let us find BC. BC. Again by distance formula BC, we will be getting x3 minus x2 the whole square plus y3 minus y2 the whole square under the root x3. x3 is 2. 2 minus x2 is 1 the whole square plus y3 is minus 3 minus 0.5 the whole square. What are we getting? 2 minus 1 is 1 square plus minus 3 minus minus will become plus, minus 3 minus minus plus 0.5 the whole square, which is equal to 1 minus 3 plus 0.5. 1 is minus, 1 is plus, so it will be subtraction. So 3.00 and 0.5 subtraction do 10 minus 5 is 5 and 2.5. So it will be plus minus 2.5 the whole square. Again minus 2.5 the whole square will be 6.25. 1 plus 6.25, that is going to be equal to 7.2. Question number, sub question 2 of 2, determine whether the following points are collinear or not. The points are P, Q and R. Let us find the distance by distance formula, children. PQ is equal to under the root, this is x1, y1, x2, y2 and this is x3, y3. So x2 minus x1 the whole square plus y2 minus y1 the whole square. Place the value, children. You can also solve yourself. x2 is 2 minus x1, 1 the whole square plus y2 is 8 upon 5 minus y1, that is 2 the whole square. Now here it is a fraction, so see, I'll be doing it, pay attention here now. This is upon 1, cross multiplication we have to do, children. Now see, 1 8s are 8 minus 5 2s are 10 upon 5 1s are 5 the whole square, which is equal to 1 square means 1 plus 8 minus 10 is minus 2 upon 5 the whole square. Now this has to be squared. 1 plus minus 2 means 4 upon 25. Again we got a fraction here, children. So upon 1, 25 plus 1 into 4 upon 25, 1s are 25 the under root. 25 plus 4 is, this is PQ, children. So 25 plus 4 is 29 upon 25. So this is PQ distance. Let us find out QR distance, children, by distance formula only. By distance formula you need to write down. Now in QR, x3 minus x2 the whole square plus y3 minus y2 the whole square. x3 is 3 minus x2 is 2 the whole square plus y3 is 6 upon 5 minus y2 is 8 upon 5. 8 upon 5 the whole square. which is equal to under the root 3 minus 2 is 1 square plus denominators are same, so you can do subtraction at the top, minus 2 upon 5 the whole square, which can be written as, see here was also 1 plus minus 2 upon 5 the whole square. We did this 1 plus square is 4 upon 25. So 1 plus 4 upon 25, and now cross multiply. So under the root 25 plus 4 upon 25, which is equal to 29 upon 25. So even QR we got 29 upon 25, children. Now let us find the PR. So PR by distance formula, children, x3 minus x1 the whole square plus y3 minus y1 the whole square. Place the values. x3 is 3 minus 1, 3 minus 1 the whole square plus y3 is 6 upon 5 minus 2 the whole square, which is equal to 3 minus 1 is 2 square plus upon 1 cross multiply 6 minus 10 upon 5 the whole square, which is equal to, children, 2 square means 4 plus 6 minus 10 is minus 4 upon 5 the whole square, which can be written as 4 plus minus 4 is 16 upon 25. Now when we will add them, again we have to do cross multiplication, children. 25 4s are 100, 100 plus 16 upon 25, which is equal to 116 upon 25 under the root. So 116 upon 25 is PR. PR is the largest distance, children, 116 upon 25, and QR is 29 upon 25, and PQ is also 29 upon 25. So by comparing, this is 1, this is 2, and this is 3. Let us add these two distances and see whether we get the third distance or not. Let me rub this part here, children. So PQ plus QR, let us see what we get. PQ is under root 29 upon 25 plus this is also 29 upon 25, 2 times 29 upon 25. If 2 will go inside, that would be 29 upon 25 into 4. 29 upon 25 into 4, let us multiply. 29 into 4, 4 9s are 36, 4 2s are 8, 9, 10, 11, 116 upon 25. So we got under the root 116 upon 25. This is PQ plus QR. PQ plus QR. The fourth statement. If you compare the fourth statement with third, you get PQ plus QR, you are getting equal to PR from what? From fourth and third. From fourth and third. And we can say point P, Q, R are collinear, because the sum of the two distance is equal to the third distance. You can pause and you can solve. Third sub question of 2, we need to find whether they are collinear or not. Again by distance formula, children. Let me write here by distance formula. So we can use the entire board. Okay, first we will find out LM under the root x1 y1 x2 y2 x3 y3. LM x2 minus x1 the whole square plus y2 minus y1 the whole square, which is equal to x2 is 5 minus 1 the whole square plus y2 is 3 minus 2 the whole square. We are getting it 4 square plus 1 square, that is under root 17. So we got LM as under root 17. This is first statement. Now find out MN under the root x3 minus x2 plus y3 minus y2 the whole square under the root x3 is 8 minus 5 the whole square plus y3 is 6 minus 3 the whole square, which is equal to 8 minus 5 is 3 the whole square plus 3 the whole square, which is equal to 9 plus 9, that is equal to under root 18. This is your MN second statement. Go for LN. LN under the root. Now x3 minus x1 the whole square, because see we are considering L and N. So distance between L and N. So x3 minus x1 plus y3 minus yn1 the whole square under the root x3 is 8 minus 1 the whole square plus y3 is 6 minus 2 the whole square, which is equal to 8 minus 1 is 7 square plus 6 minus 2 is 4 square under the root 49 plus 16, which is 40, 59, 65 under the root. 40, 59 plus 1, 65. Okay. So ln is under root 65. ln is larger than this 2. Let us see if I add them, I get this or not. Let us see. See children, now this is under root 17 and this is under root 18 and this is under root 65. So this is the largest distance under root 65. Let us compare them whether they are equal or what. I will take LM plus MN and find out how much it is. Under root 17 plus under root 18. We can't add them, and ln is under root 65. We can add them by squaring both the side. That squaring both the side also I will show you how it is. But it is very clearly visible here itself. Okay, root 65 cannot be equal to this 2. So lm plus mn, if I am squaring, what am I getting? Root 17 square plus 2 into root 17 into root 18 plus root 18 square. Root 17 square is 17 plus 2 under the root, multiply 306 plus 18. 18 plus 17 is 35 plus under root 306 into 4, and 306 cannot be factorized. So it will be giving you a root answer only. That means this is sum of this 2 is not equal to this 2. Further we can do it. See, 35 plus 4 6 are 24, 4 zeros are 1 2 2 4, 1 2 2 4 plus 35 and 1 2 2 4 square root. Question number 3 of problem set. find the coordinates of the midpoint of the line which is joining P and Q. So there is a line segment. We join point P and point Q. The coordinate of point P are 0, 6 and coordinate of point Q are 12, 20. And we need to find out the midpoint of this. Coordinates of the midpoint. Let us say M is the midpoint and the coordinate of the midpoint is x, y. Point P is x1, y1 and point Q is x2, y2. M is the midpoint. So naturally, if we want to find out the coordinate of the midpoint, then we will be using the midpoint formula. So M is midpoint and it is given and therefore by midpoint formula. Therefore by midpoint formula. So x coordinate is equal to x1 plus x2 upon 2 and y coordinate is equal to y1 plus y2 upon 2. Now place the value of x1. x1 is how much? 0 plus x2 is 12 upon 2. 12 upon 2, 2 ones are 2 6 are. So x is equal to 6. Now here y is equal to y1. y1 is how much? 6 plus y2 is 20 upon 2. So that is 26 upon 2. So y coordinate will be 2 ones are 2 threes are 6. So y coordinate is 13. So we got here x and y coordinate of M as x is 6 and y is 13. You can pause the video and you can solve the sum. Question 4th of problem set. In this we have to find the ratio in which line segment joining the point A and B. This is the point A and this is the point B. This is the line segment which join the point A and B. So this line segment is divided by y-axis. Means AB is divided by y-axis. This is y-axis and this is x-axis. So we want to find out that y-axis will divide this line AB in which ratio? Okay. So A coordinate is 3, 8 and B coordinate is minus 9, 3 and we need to find out the ratio. So let us say that point M is the point where y-axis divide the line AB. So what will be x and y coordinate of point M? As the point M is on y-axis, so its x coordinate will be 0, children, and we need to find out y coordinate. Fine. So here we are not supposed to find y coordinate, only we are supposed to find out the ratio in which y-axis divide the line segment AB. So we know x coordinate. So by distance formula, here children we have to use distance formula because see we are asked ratio and two coordinates are given A and B ka, that is x1 y1 and x2 y2. So we can use distance formula here and x coordinate we know 0. So by distance formula x is equal to m x2 plus n x1 upon m plus n. Why I am using x1? Because x is given, x1 is also given, x2 is also given, so we can get m and n. Now here x is 0, place the value, m we don't know, x2 is minus 9 plus n we don't know, x1 is 3 upon m plus n. M plus n will go here, multiply with 0 and will become 0. So minus 9m plus 3n. This is m and this is n. We will shift 9m variable to other side of the equal and we will get 9m equal to 3n. Now children, m is this side, n is this side. Bring this n this side and 9 will go here. So let me write again. See, I don't want n here, so I will bring it n here. I don't want 9 here. Where will 9 go? 9 will go down. So m upon n upon n is equal to 3 ones are 3 threes are 1:3 or 1 upon 3. So y-axis will divide line AB in the ratio 1:3. So you can write here y-axis divides AB in ratio 1:3. You can pause and you can solve the sum, children. Question 5 from problem set. We have to find the point on the x-axis. The point is on the x-axis and that point is at equal distance from Q and from P. That means QM is equal to MP. Equal distance from Q and from P. Now Q is here. Q is what? Minus 2, 9, this point. And P is here minus, P is here 2, 1, 2, 2, minus 5. So this is the point P and this is the point Q. From this point, if I join, my point is on x-axis and I don't know where it is. If my point is on x-axis, its y-coordinate will be 0. Let M be the point which is on x-axis. If the point is on x-axis, the point's x-coordinate will be, y-coordinate will be 0. Its y-coordinate will be 0 because the point is on the x-axis. So we need to get x-coordinate. X-coordinate can be anywhere. It can be here, 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 or it can be here. It can be to the left, it can be to the right, and it is not mentioned whether it is right or to the left, but it can be anywhere. Okay? It is not exactly in one line. It is also not mentioned that the point P, M, Q are in one line. If they would be in one line, then we would have used the distance formula and we could have done. But it is not mentioned that. It is mentioned that point M is on the x-axis and that point is at equal distance from Q and from P. Means MQ is equal to MP. Understood? That point M is on the x-axis. That point can be anywhere. It can be here. If the point M is here, then MQ is equal to MP. If that point is here, then MQ is equal to MP we have to take. If that point is here, MQ is equal to MP. Like that. So that point is at equal distance from the point P and Q, and here we cannot use the distance midpoint formula because the line points are not given collinear. So what can we use? We can use distance formula. We can use distance formula. Now what we need to find out? We need to find the point. Where is that point? So of that point y coordinate we got, but we did not get the x coordinate. So we can use distance formula and we know MQ is equal to MP and it is given only. Okay, let us find MQ by distance formula. This point, suppose if point M is x0, then Q is x1, y1, P is x2, y2, and we need to find out, suppose this point is like this, P and Q, point M is here, MP is equal to MQ, x comma 0, and this is x1, this is x2 y2, and this is x1 y1. So what would be MQ distance? MQ would be x1 minus x, x1 minus x the whole square plus y1 minus y the whole square, because these points I am taking as x comma y, m, okay, is equal to MP. Now MP is again this x2 minus x, x2 minus x the whole square plus y2 minus y the whole square. Now we will place the value, children. First we will square both the side. Squaring both side, root will go. Then x1. x1 is how much? x1 is minus 2. See there, minus 2. Minus 2 minus x. X we don't know. The whole square plus x2 is plus y1. y1 is how much? 9 minus y is 0 the whole square is equal to, now x2 is 2. See, I am seeing there, see children, x2 is 2 minus, and x we don't know, x the whole square plus y2 is what? Minus 5 minus y. What is y? 0 the whole square. Now minus 2 minus x the whole square. This is a minus b the whole square. What is a minus 2? So a minus b the whole square is what? A minus b the whole square is a square minus 2ab plus b square. Okay. Now what is a? A is minus 2 and it is minus x. So what will come? A square means minus 2 square minus 2 into a. What is a? Minus 2 into b is what? X. Not to take minus. That minus we have taken already here because a minus b. Okay. Plus b square means x square plus 9 square is equal to, again a minus b the whole square. A minus b the whole square is what? 2 square minus 2 into x plus x the whole square, and minus 5 minus 0 is plus minus 5 the whole square. Now 4 minus plus 4x plus x square plus 81 is equal to 4 minus 4x minus 2 to the 4x plus x square plus 25. Minus 5 the whole square will be 25. See, now what will get cancelled, children? Plus 4 and plus 4 will get cancelled. Plus x square and plus x square will get cancelled because in the middle equal is there. This side x square which is plus, this side x square which is plus. Now 4x and minus 4x. Minus 4x will come here. 4x plus 4x. So we have taken this, we have also taken this. And 81 I will shift there. 25 is already there. 25 minus 81. 4x will be 8x. 8x is equal to sign of the greater number minus, and 81 minus 25 I think 56. 81 minus 25. 11 minus 5 is 6 and 7 minus 2 is 5. So minus 56. Now x will be equal to minus 56 upon 8. 8 sevens are. So x is equal to minus 7. We got the coordinate of point M. That means our point M is this side, not that side. So somewhere here it will be minus 2, minus 3, minus 4, minus 5. Somewhere here minus 7. So the point M is here on the right side of the y-axis, left side of the y-axis. This side is the left side, and that would be minus 7, 0. So you can pause the video, children, and you can solve the sum.